Good morning, everyone. It's Mrs. Metzger. Today's topic is similar polygons. This is the note packet that you're going to need for today's lesson. In our last lesson, we talked about similar figures. So just something to remember, if you know that two figures are similar, they're going to have two criteria. The first, all the corresponding angles are congruent. So even though the size might be smaller or larger, all the angles in their correct positions should still be the same. The second aspect is that the lengths of corresponding sides are proportional. That means we should be able to look at two corresponding sides, establish the ratio, whether it's small to big or big to small, and that ratio should be present on all sets of corresponding sides. So we're going to move on to polygons. Today, polygons are three sides or more. And if you know that two polygons are similar, the same criteria applies. The ratio of the sides of any two corresponding sides should be the same, constant. And then as you travel around the figure, you should find that same ratio. So every side is in proportion. We call that ratio a scale factor or a constant of proportionality. We use the variable k to represent the scale factor that will exist between each ratio and each set of corresponding sides. Here's an example that I drew. I drew two similar rectangles, and I randomly just made up the numbers. There's really no science behind it or math. I said on my rectangle, two of the sides are 1 and the opposite sides are 2. And then on the bigger figure, the sides are 5 and 10. If I start here with side 1 on the left, I will compare it with side 5 also on the left. So going from small to large, I'm establishing a ratio of 1 to 5. So K, my scale factor, is 1 to 5. If I look at the sides on top, 2 is to 10. That's also the value of K, and you can see that it reduces to 1 to 5. So if I work my way around the figures, you're going to see that 1 to 5 exists between all four sets of sides. In this example, what we have are two similar triangles. We can see that they're similar. They've marked corresponding angles at A and D, C and B, and then here at E we have vertical angles. And of course, we would use 3 letters to distinguish those. On your figure, we have to be able to figure out the scale factor K. If you look at side AC, it's 36, and that corresponding side is DB, which is 24. Because both of those sides are present, that will establish K for us. So K is 36 to 24. And of course, you can reduce this ratio, and it will make your calculations easier when you do that. We're going to find the missing pieces then. So we're going to use the ratio of 36 to 24 in our proportions. I'm going to start by solving for x. So you can see my ratio here, 36 to 24. Let me go back. Because I started with the bigger figure on top, I need to start with the missing side or the known side on the bigger figure first. So I'm going to start with 30, and then 24 represents my smaller figure, and that will correspond to x. So you can see I have big figure on top, small figure on the bottom. We're going to cross multiply, and we're going to put it into an equation, and then we'll divide both sides by 36, and the value of x is 20. We're going to do the same thing, solving for y, and again, I'm going to start with my scale factor k. 36 is to 24. Remember, the big figure is where we want to start for the next ratio. 15 is to y. When I cross multiply, there's my equation, and y is 10. If I were to reduce k to lowest terms, there's a common factor of 12. This would be 3 to 2. If you look at the value of 20 here at x, it corresponds with 30. 30 over 20 reduces to 3 to 2. And then 15 over 10 for y is 3 to 2. So you can see that that scale factor is constant all the way around. For the next example, we have the sides of a quadrilateral provided for us, 8, 10, 12, and 15. We want to find the lengths of the sides of a larger similar quadrilateral, and they're providing the constant of proportionality k as 2 to 5. When they set it up this way, 2 represents the smaller figure, 5 represents the larger figure. So we want to make sure we maintain that ratio as we set up our calculations. I drew a random four-sided figure. Doesn't say that it's a square or a rectangle, so I made it funky. I labeled all my smaller figure sides. And then I gave the variables on the bigger figure, as well as my scale factor k. So I'm going to start by solving for x. I'm going to start my proportion with my scale factor 2 to 5. And because 2 is on the top, we want to start with the smaller figure on the top. 8 is to x. I'm going to cross multiply to solve these, but you can see the multiplier. I did 2 times 4 to get 8. So this is really 5 times 4 to get x, and x is 20. So some of these ratios will be quite simple, and a lot of math will not need to be shown. Now I'm going to do the same thing for y, starting with my scale factor of 2 to 5. So small to big. I'm going to go back to the small figure, 10 is to y. Again, to go from 2 to 10, I can see that I multiplied by 5. So 5 times 5 would give me 25 for y. Moving around to z, starting the ratio 2 to 5. We're going to go small to big, 12 to z. Again, to go from 2 to 12, I can see the multiplier is 6. So 5 times 6 makes z 30. And then finally, my missing side a, 2 to 5, small to big, and then 15 is to a. When I cross multiply here, I'm going to have 2a equals 75. You can leave it as an improper fraction if you like, 75 over 2. I did make it a decimal of 37.5. So we found all the missing sides, and all corresponding sides are in a ratio of 2 to 5. For our last set of examples, they're telling me that triangle ABC is similar to triangle XYZ. That means the angle measures and corresponding positions are the same, and the sides should be in a consistent ratio. So for number 1, the scale factor of triangle ABC to XYZ, we need to go little to big. So we're looking for sides that would be listed. I have AB and XY. That's going to establish K for us. So the scale factor is 6 to 10. And of course, we want to reduce to lowest terms. They have a common factor of 2, so this is a ratio of 3 to 5. For number 2, what they're doing is switching the order. They want me to go from triangle XYZ to triangle ABC. All I need to do is flip my original ratio over. So in number 2, the ratio is 5 to 3. They're asking us the same information in step 3. So the ratio of side BC, which is on the smaller figure, to side YZ. Even though we don't know the ratio of, or the value of side CB, it doesn't matter. We know to go from small to big, it's 3 to 5. I'm going to jump down to number 6. What they're asking for is side XZ over here on the larger figure, right here, to side AC. Again, it doesn't matter that I don't know XZ. Because I'm going big to little, the ratio's flipped over and it's 5 to 3. We're going to skip number 4 and 7. They're a little bit confusing, and they're not really going to help you in your homework anyway. For number 5, they're looking for the value of BC. So I need to start with writing my proportion for number 5. I know that the ratio is little to big, 3 over 5 equals, I'm going to call BC x. So I'm going to go back to the small figure, and the side that corresponds to BC is 20. You can see in the numerator or the denominator, 5 times 4 would give me 20. So 3 times 4 would give me x equals 12. And I'm not very good with this pen, so we're just going to send it. The last problem, number 8. They want us to find the missing side xz. I'm going to call this y. And I'm going to start with my ratio of 3 to 5. And then I'm going to return to the smaller figure. The side that corresponds is 9 to y. And again, to go from 3 to 9, I'm multiplying by 3. 5 times 3 will give me y equal to 15. Hopefully that makes some sense. This is homework number 99, similar polygons. Some of it will have work to be shown. Make sure you establish your scale factor k. If you're going through your homework and you have trouble, please make sure you give me a call. You can call me on my home phone. You can call or text me on my cell phone, or you can just send me an email. Please make sure that you are completing the homework. Probably I'll be asking you to send it to me through email or through a text very soon. Have a great day.